Hello everyone. Before we start, my congratulations thanks to the Ground 2021 and 9th LPE Organization Committee. Moreover, thank you all for your time and attention. My name is Mauricio Ferreira Guimarães, engineer at CEMIG and doctoral student at Federal University of Minas Gerais. I presented the paper Original Setup to Measure Ground Impedance and Resistance using auxiliary electrodes buried vertically in the ground. In my talk I will cover basic aspects of this new experiment and preliminary result of these techniques that I call vertical LIA in the ground. More details can be found in the paper and the cited references. CEMIG is an integrated utility company with a national presence in Brazil. Our headquarters is located in Minas Gerais capital, Belo Horizonte City. CEMIG runs the biggest distribution company in Latin America. Here we have the summary for orientation, and just let's go ahead to the next slide. Before all, it's always important to remark that ground is about safety and reliability. As a general design criteria, resistance measurements must be performed after structural substation grid assembly. Also, ground measurements are a criterion for maintenance and asset assessment throughout the life cycle. Measuring ground impedance is not a widespread practice. It's important to know that field conditions are always challenging, and this is a strong motivation for this work. As we can see on these peaks of electrical assets in urban area, we face different difficulties, like lack of space for auxiliary cables of measuring circuits, remote earth hardly accessible, influence of interconnected circuits, interferences between other issues. In this work, we use the concept of transient impedance that, as we know, can be retained from instantaneous values of current and potential. We use the fall of potential method associated with an impulse generator with double exponential form. For this kind of measurements, we do need to pay attention to the necessity of widespread long auxiliary cables for current and potential circuits, and the effect of interconnected circuits like the guy wires of towers of transmission lines. The key element of the new technique is, as we call it, the LIA, a Portuguese term for artificial infinite line. And LIA is actually a slow wave structure with approximately 30% of light speed propagation velocity. We can calculate the LIA parameters, velocity and impedance using a solenoid approximation for inductance and a transmission line approximation for capacitance. With the LIA slow propagation velocity, we create a suitable time window for data signal acquisition. For reference, the LIA we use in the experiment has a propagation velocity of 7 meters per microsecond, approximately. The LIA method above the soil was originally tested successfully in field conditions at a 188 kV line Jabuticatubas Pedro Leopoldo III. A 6-meter LIA was used in the set to measure the tower foundation and the counterpoise ground resistance and transient impedance. After this brief preparation, we can talk about the method of vertical LIA in the soil. In this picture we can see one 18 meters long electrode and two 12 meters deep hole in the ground near both terminations. In one pit we fixed a conventional cable and a rod at the bottom, and the other pit was free to LIA descending. PVC pipes were used to protect the walls of the pit. So, as you can see here, the vertical LIA method demands drilling the soil. Standard orientation method is a very common geotechnical activity for new structure of building foundations. Costs are in order of $10 and $20 per meter. This is an affordable cost. Here we have the setup of the measuring circuits for case 1 and 2. We are measuring the impedance of one horizontal ground electrode. In case 1 we have the LIA over the ground, and in case 2 we have the LIA vertically disposed of in the ground. In both cases the LIA is perpendicular to the potential auxiliary cable. So there is a mutual coupling between the potential and current circuits. In this setup, the LIA works as a source impedance in the current circuit. For comparison, we have measured the DC resistance with conventional equipment. The measured DC resistance is 6.6 ohms. In these graphs, we can see the currents for case 1 and 2 and the corresponding voltage curves. After 4 microseconds, we can observe the reflected waves. And finally, we can observe in this graph the transient calculated impedances for cases 1 and 2. We can see a nice correlation with the DC measured resistance, 6.6 ohms. Now cases 3 and 4. The measuring setups for case 3 and 4 are very similar to previous cases, but we extended the potential lead orientation using a vertical cable connected to a steel rod in the butt of the second hole. The LIA was kept as a source impedance over the ground, and with this setup we keep the perpendicular orientation between the potential lead and the current circuits in both cases. In these graphs we can see the measured current and voltage curves for cases 3 and 4. And here the transient impedance curves for case 3 and 4. Again, we can see a strong correlation with the DC measuring resistance. We have done a comparison between measured and theoretical values for transient ground impedance using the P-SPICE program. For the ground electrode, we use the T-loss model of P-SPICE program. We can see from the graph that in all cases the simulated results are close to transient impedance derived from current and voltage data. Here some talks for discussion, and we are heading to the end of this presentation. Based on the work we have carried out to this point, we can say that the transient impedance is very little affected by the LIA space orientation. Indeed, we can put the LIA vertically in the ground, avoid the coupling between measuring circuits, keep the advantage of the perpendicular orientation between current circuits and the potential lead. From the data we have collected, we have observed a strong correlation between measuring DC resistance and DC values obtained from the transient impedance data. In the same direction, there is a nice correlation between the transient impedance and the theoretical T-loss model used in P-SPICE simulation. That's a good point. And indeed, vertical LIA in the ground is a new way to obtain the remote Earth. And for this, the LIA technique for ground measurement can be used in narrow spaces with advantages. Initial results are encouraging, however, new measurements are needed to validate the applicability of this new technique. And here are the conclusions. We presented on the paper a new setup for measuring impedance and resistance with the auxiliary electrodes vertically disposed in the ground. The new method demanded drilling the soil, but the costs are acceptable. And the infinite artificial line as a short reaction lead, it's a very flexible solution for ground measuring narrow spaces. Vertical laying in the ground is indeed a new way to obtain the remote Earth. And at last but not least, we are planning new experiments to fully method validation. And that's all. Thank you very much for your time and your attention.